Hello again, everybody. Welcome to another math video. This is a continuation for assignment 10 notes for ABS, aka graphing lines using slopes and intercepts. So we're looking at slopes. The last video we went over all of the slopes, how to find a slope from a graph, and then we had some special slopes thrown in there with the undefined slopes for vertical lines and the zero slopes for horizontal lines. Well, now we're taking away the picture. We're taking away the crutch and actually going through the math. You'll notice here at the top, finding the slope given 2 points, we have a little equation. This is known as the slope equation. Cool. M is the variable we use to represent slope in linear functions. And you can find out what the slope is if you take the difference of the y's and divide it by the difference of the x's. Now, some of you out there may have trouble keeping this straight, so I'm going to go over a little technique that I like to use right now in order to find the slope very consistently. So I've labeled the two ordered pairs that I have here. And these two ordered pairs each have an x and y coordinate. So I have here ordered pair number 1 and ordered pair number 2, which would make this x coordinate x1 and this coordinate y1. The y value of the first point, the x value of the first point. Pretty simple. For this ordered pair, I have the x value for the second point and the y value for the second point. That's how I'm going to keep all this straight. So the equation looks like this, and I encourage you to write it down every time you work through an example. So there it is, and I'm going to just plug in the numbers. So there we go. Look at that. The y value in the second point, we say y sub 2, sub for subscript. So y sub 2, y from the second point is 4. Boom, there's my 4. Minus y from the first point, or y sub 1. Y from the first point is 3. Boom, there's the 3. 4 minus 3 in the top. y2 minus y1. All over x sub 2, the x value from the second point, 3. There it is. And x sub 1, the x value from the first point is 1. There it is. Then we just follow our order of operations. We simplify the top to be 1. We simplify the bottom to be 2, right? 4 minus 3 is 1. 3 minus 1 is 2. And then we simplify the fraction if you need to. In this case, we don't need to. It's 1/2. That's awesome. So that's what it looks like to find the slope of a line given 2 points. Now I'm going to leave number 8 for you to try. I want to skip right on over to number 9. Because number 9 presents a very interesting issue. Here, 1, x, y, 2, x, y. So y sub 2, if we're using our formula here, m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Y sub 2 is 3. Y sub 1 is 6. So 3 minus 6. X sub 2 here is 5. And x sub 1 is 5. So in the numerator, I've got -3. In the denominator, I have 0. 0 in the denominator of a fraction is about the worst thing you can have happen to you in a math class. Nobody knows what dividing by 0 means. And therefore, it's never been defined. So we say, anytime you have a 0 in the denominator of a slope, this is an undefined slope. Pause the video, try example 8 for yourself, and I'll be back in 5 seconds. Ta-da! All right, so with example 8, you can see where y2 came from y1 came from, x2 came from, and where x sub 1 came from. Now the only thing that you must absolutely remember is that these minus signs are, in fact, in this formula up here. So they should appear here every single time. What happens here is when you're subtracting a negative, you are really adding a positive. So negative 8 plus 2 is why we have a negative 6 in the denominator. So negative 6 divided by negative 6 gives you a 1. Perfect. So that's the slope for example 8. The only slope I did not get an example in here for is the 0 slope. And that is when you get a 0 over something that is not 0. So when you get 0 over 4 or 0 over negative 5 or 0 over anything as long as it's not 0, that means you have a 0 slope. Cool. All right. Example 10, 11, 12, solving for y, not a big deal. If you're in the class I'm teaching, you've done this before already this semester. So let's run through these really quickly. I want to make sure I get all of the y terms on one side of the equation and any term without y on the other side of the equation. So that means I'm going to have to subtract my 4x here. So I'll have 3y equals negative 4x plus 21. The last step, divide by 3. But we want to make sure we're dividing all terms by 3 so that you get y equals negative 4/3 x plus 7. And I know the spacing is a little smushed there, so I will make sure I do better for number 11. But that's it. We teachers, professors, all of it, we want to see 3 terms in the equation: the y, an x term, and a constant term if there are either of those. Next, example 11. So example 11, same thing. I want to make sure I isolate the y term and move any term without y on the other side. So I would subtract 5x, which would give me negative 5x plus 10 on the right. Then I would go through and divide everything by negative 2. Not each side, each term. So the negative 2's would reduce away. This would be y equals 5 over 2x minus 5. All right, pretty simple. The negative 5 divided by the negative 2 becomes positive. Anytime you divide two numbers with the same sign, it's positive. Okay, so here is solving for y in this one. Number 12, same thing. Negative 6y equals negative x plus 12, right? Subtract the x from both sides. Divide everything by 6. Y equals negative, ooh, you know what? This one is sneaky. There is a 1 in front of this x, a negative 1 as a matter of fact. And you want to remember that that is a 1 when you're going through and solving for y. So here we have y equals negative 1 over 6 times x plus 2. Why is all of that important? Well, I wanted to get it done in this video, so I'm going to go a little bit quickly here. When you solve for y and you simplify the right side down completely, what ends up happening is it gives you the slope and the y-intercept in the equation. How does that help us? Well, there's the slope, right? There it is. It's m. It's the number that is multiplied to x, aka the coefficient. And here is b. b is not technically the y-intercept. It's the y-coordinate of the y-intercept. And what is a y-intercept, you may be asking? A y-intercept is where the graph will intersect the y-axis. So in this case, the y-intercept here will be 0, negative 1. That's where this negative 1 goes. Oops, there we go. It goes into the y coordinate of the y-intercept. And our slope then for this line is 3 over 2. And remember, that just means rise over run. Why is all of that important? Because if we want to graph this line, we can come over and we can start with the y-intercept, or one may say even begin with the y-intercept. I feel like that's a good reason why they use b. Begin with this. So begin with the point, and then we just follow what the directions of the slope. This is a positive 3 over a positive 2, so I will rise 3, because it's rise over run, rise is on top, 3. And I will run 2. And I realize that point is off, so don't worry about that point. That should be right here. There we go. Rise 3, run 2. All right. From there, I would rise 3 again and run 2 more. From there, I would rise 3 again and run 2 more. Cool. So that's what my line is starting to look like. But going the other direction, right, I want to make sure you know how to graph going both directions, but it looks like the points should be to the left of where we started. Let's see. So how can we get there? Well, we just have to do exactly the opposite. Instead of going up and right and up and right and up and right, remember the slope, the first slope I did from the last video? I said you can go down and left as long as you can get from one point to the next. You're good to go. You can go up and right, or you can go down and left. So if I want to move left, then I also have to move down. So I'm going to move down 3, left 2. Does that blue point looks like it's on the same line here? Let's see. Yep, that looks pretty good. So as long as you're moving exactly opposite, you can do this. Down 3, right 2. I guess that would be right there. Does that look like it lines up on the same line? And I encourage you, grab a ruler, grab your ID, grab, I don't know, a popsicle stick. They all work. They all have flat edges on them. And yeah, that looks like a pretty good line. So you can go back and you can label it again, right? I did some of that. As y equals 3 over 2x minus 1. That is the equation of that line. And in the next video, which should be popping up any second now, I will be going over many more examples of how to graph from slope-intercept form, and I will finish up with how to graph lines using their x and y intercepts. Good luck, everybody.